In this video, I'll be introducing you to arithmetic sequences. So, an arithmetic sequence is a sequence or a list of numbers in which each number is obtained by adding the same fixed number to the previous number. What do I mean by that? So, let's look at an example, and that's probably one of the easiest ways to see exactly what I mean here. So we have 7, 10, 13, 16, 19, and it goes on and on and on. Okay, this is an arithmetic sequence, and here is why. I'm adding the same fixed number each time to get the next term. So in every single case, I'm adding 3, and that's 3 in this example. It could be another number to get the next term. So it would be, if I asked you 1, 2, 3, 4, 5, if I asked you for the 6th term, that would be pretty simple to find. I would just have to add 3 again, right? However, if I asked you for the 178th term, it would be a little bit more challenging. I mean, nobody wants to sit here and add 3 to a number 178 times. So, how would we go about figuring out the 178th term or any term? So, we're going to come up with a formula together, because I think it's a little bit boring if I just give you the formula. We'll come up with the formula together, and then after we come up with that formula, you'll never have to come up with the formula again. You can commit it to memory, write it down, whatever you need to do. All right, so before we come up with the formula, let's name things. So for the word term, we're actually going to use a U. I don't know why, because U is not in the word term, but that's the letter that we use for the word term. All right, so this is the first term. We write U sub 1. So U little 1 there. The second term, we would write U2, U3, U4, U5, so on and so forth. So the first term is, as we just saw, called U1 for term 1, first term. The nth term, so any term, which is also known as the general term, so let's call it the general term or the nth term, is U sub n, which means n could be any number. It could be 5, it could be 5 million, it could be 500,000, doesn't matter. N is any term. All right, what else do we need to know? Well, n is where the term lies. So, for example, if we're talking about the first term, n is 1, but if we're talking about the 50th term, n is 50. So, n is the position of the term. And d is the fixed number that we're adding each time. So in this case, that fixed number that we're adding each time is 3. And we call it, for short, not the fixed number that we're adding each time, we call it the common difference. Alright, so now that everything has a name, now we can quickly come up with the formula and use it, have a good time using it. Alright, so I'm going to turn the page, but you'll see everything when I turn the page. Okay, so the first term is just the first term, right? We didn't add anything else to it yet. But the second term, we have to add d to U1. That's supposed to be the 2 for the second term. Now the third term, we would go ahead and we would add d once again. And we would keep doing that. So for the fourth term, we would go ahead and add d one more time. So notice here, every single time I add a term, so I'll just put one more on here, U1 plus d plus d plus d plus d. So every time I add, I go one term further. So when I'm here on the 5th term, I'm adding 4 d's. When I'm here on the 4th term, I'm adding 3 d's. When I'm here on the 3rd term, I'm adding 2 d's. So really, I'm adding a bunch of d's each time, but the number of d's that I'm adding is 1 less than the term that I'm looking at. So if I kept going on and on and on, and I was on the nth term, any term, then I'm going to be adding 1 less d than n. So I'm going to be adding n minus 1d. All right, so that's how I came up, well, I came up with the formula. I'm so fancy. No. I didn't come up with this formula, but that's how somebody one day came up with this formula, and that's what I'm showing you today. So if you don't know how to derive that formula, that's completely okay. All you have to do is know how to use it, actually. So the formula un is equal to u1 plus n minus 1d. That is a formula to find any term in a sequence. It is also called the general term formula. All right, so we're going to go ahead and use it in an example. Okay, so here we're being asked to find the 30th term of the sequence. And as we know, it's jumping by 3 each time. So that means our common difference is 3. So we need to know that information. We also need to know that it's starting off the first term at 7. So now with that information, we can plug into the formula that we just learned, which is un equals u1 plus n minus 1d. And it's just a matter of plugging in. So the 30th term, which means n is 30, the position of that term is 30. So u30 is equal to u1, which is 7, plus n, which we just figured out was 30, minus 1, times d, which is 3. And when we plug that all into our calculator, we see that u30, the 30th term, is 94. All right, so that's how we find a specific term, but we can actually use this formula to find a general formula for any sequence. So we're going to look at how to take our general formula for every arithmetic sequence and scale it down to a specific sequence. Okay, so in this example, I am being asked to find the general term of the sequence. I'm not asked to find a specific term. I'm not asked to find the 30th term or the 22nd term. I'm just asked to find a formula which will give you any term for this particular sequence. Well, we do know that this formula, un equals u1 plus n minus 1d, gives you any term for any arithmetic sequence. Now we're going to scale it down to this particular sequence, find a formula for this sequence. So since it's general, un will stay as un because that's general, and n will stay as n because this is for any term. But we're going to plug in what we do know, which is u1 and d. So u1, the first term, is 100, and this particular sequence is going down by 4. Because it is going down by 4, that does not mean our common difference is 4. Our common difference is what we add each time to get to the next term. So what is our common difference here? Did you say that d, our common difference, is -4? Hope so. If you did, you're right. Okay, so un is equal to u1, which is 100, plus n minus 1 times d, which is -4. At this point, we can distribute our -4, and we get that un is 100 minus 4n plus 4. So I just distributed that -4. We multiplied. All right, and now we can take care of our like terms, and we get that un is equal to 104 minus 4n. So now that formula will tell you any term of this particular sequence. So that's how we find the general term, also known as the nth term. All right, and that's it for now.